Reaction yield. For a generic chemical equation like this one here, A plus B goes to C, there's an amount of limiting reagent present at the beginning of the chemical reaction. And this limiting reagent will determine the theoretical product yield. So what this means is that either A or B will determine the maximum amount of product, C, that can be formed. The theoretical yield is the amount of product that would result if the limiting reagent, which is either A or B, reacts all the way to completion. So one of these guys here in this chemical expression is going to be a limiting reagent. The theoretical yield for this chemical reaction is a result of one of these chemicals, either A or B. We haven't determined which is the limiting reagent yet, reacting all of the way to completion to form the maximum amount of product, which is C. Now, the actual yield in a chemical reaction will always be less than the theoretical yield. And this is just simply because no chemical reaction will go all the way to completion. Therefore, we define the actual yield is the amount of product that is actually obtained by the chemical reaction. In order to describe how efficient a chemical reaction is, chemists often use an expression called the percent yield. And this is a very simple expression. Percent yield is just the actual yield divided by the theoretical yield and then multiplied by 100 to convert your decimal into a percent. Now, the desired outcome of this expression is obviously 100% because that means you would have achieved your theoretical product yield. But this is rarely, if ever, achievable in practice. And that's just because chemical reactions don't usually go all the way to completion, meaning all of the limiting reagent reacts in order to produce the maximum amount of product. So we define reaction yield and we can move on to the example. Titanium tetrachloride is an inorganic compound with the formula TiCl4, meaning there are 4 chlorine atoms to every 1 titanium atom. And this is an important intermediate in the formation of titanium dioxide. And titanium dioxide is widely used as a pigment in industry. Upon contact with warm, humid air, titanium tetrachloride forms opaque clouds of titanium dioxide and hydrochloric acid. A. Write the balanced equation and determine the theoretical yield if you react 3.54 grams titanium tetrachloride with 1.13 times 10 to the 7th grams H2O. And then B, calculate the theoretical yield if from the reaction you obtain 7.91 times 10 to the 6 grams titanium dioxide. So the first thing that we need to do is we need to balance our chemical reaction. Titanium tetrachloride combines with H2O to yield titanium dioxide and hydrochloric acid. So we can begin by balancing the chlorine by putting a 4 in front of hydrochloric acid. So that balances the number of chlorine. So we have 4 on this side and 4 on this side. And so we can move on now to the hydrogen. We've got 4 hydrogen on this side and only 2 on this side. So if we put a 2 in front of H2O, now the hydrogens are balanced. So let's double check to make sure that this equation is balanced. We have one titanium atom on this side, one titanium atom on this side, or I should say 1 mole of titanium, 1 mole of titanium on this side, 4 moles of chlorine on this side, 4 moles of chlorine on this side, 4 moles of hydrogen on this side, 4 moles of hydrogen on this side, and 2 oxygen and 2 oxygen on this side. So what this chemical reaction says is that 1 mole of titanium tetrachloride combines with 2 moles of H2O or water to yield titanium dioxide and 4 moles of hydrochloric acid. So now we have our balanced chemical equation right here. In this chemical equation, we have 2 reactants. We have titanium tetrachloride and we have H2O. One of these will be our limiting reagent. The limiting reagent will produce fewer moles of titanium dioxide because that's our desired product. So the limiting reagent is the one that will produce fewer moles of titanium dioxide. To determine the theoretical product yield, let's first start with titanium tetrachloride. So the problem statement said we have 3.54 times 10 to the 7th grams of titanium tetrachloride. Well, we need to convert our grams of titanium tetrachloride into moles because this balanced chemical equation is written in terms of moles. It's not written in terms of grams. It says 1 mole of titanium tetrachloride combines with 2 moles of H2O to yield 1 mole of titanium dioxide and 4 moles of HCl. So we do this by using the molar mass of titanium tetrachloride. So the molar mass says that 189.68 grams of titanium tetrachloride is equal to 1 mole. So you set up your conversion factor, grams of titanium tetrachloride cancels, and you see that you have 1.87 times 10 to the 5th moles titanium tetrachloride. So let's see how many moles of titanium dioxide is produced by 1.87 times 10 to the 5th moles titanium tetrachloride. Well, in this balanced chemical expression, we see there is 1 mole of titanium tetrachloride to 1 mole of titanium dioxide. So you set up your ratio here, moles of titanium tetrachloride cancels, and you see that 1.87 times 10 to the 5th moles titanium tetrachloride produces 1.87 times 10 to the 5th moles titanium dioxide. Now you repeat the process for H2O. So you convert your grams of H2O into moles of H2O by using the molar mass of H2O, and you see that 1.13 times 10 to the 7th grams H2O is equal to 6.27 times 10 to the 5th moles H2O. So let's see how many moles titanium dioxide is produced by the reaction of 6.27 times 10 to the 5th moles of H2O. Well, we see that there is 1 mole of titanium dioxide to 2 moles of H2O. So 2 moles H2O to 1 mole titanium dioxide, moles of H2O cancels, and you see that 6.27 times 10 to the 5th moles H2O produces 3.13 times 10 to the 5th moles titanium dioxide. Well, 1.87 times 10 to the 5th moles 1.87 times 10 to the 5th moles titanium dioxide is less than 3.13 times 10 to the 5th moles titanium dioxide. So we know that our limiting reagent must be titanium tetrachloride. And that's just simply because it produces less moles of our desired product, which again is titanium dioxide. And quickly, we can determine the percent yield by converting our moles of titanium dioxide to grams of titanium dioxide, again, by using your molar mass principles. And the molar mass of titanium dioxide is 79.866 grams, so 79.866 grams is equal to 1 mole of titanium dioxide. Moles cancel. We have a theoretical product yield of 1.47 times 10 to the 7th grams titanium dioxide. Percent yield says actual yield divided by theoretical yield times 100. So our actual yield was given in the product statement is 7.91 times 10 to the 6th grams titanium dioxide. So this yield, your actual yield divided by theoretical yield, which we calculated, is 1.47 times 10 to the 7th grams titanium dioxide. You multiply this by 100 to convert your decimal into a percent, and you see that your percent yield for this chemical reaction is 53.80%.